Hey guys, this is Carrie, and in this video we're going to be doing homework number 5. So on the grid below, graph and label each of the following lines. We've got the line x equals -6. So this is the line that crosses the x-axis at -6. So if we go to -6 on the x-axis, the line that crosses that will be a vertical line going straight up and down. X equals -6. Next up, we've got the line y equals 9. This is the line that crosses the y-axis at 9. So here's y equals 9. I think you can probably do the other two on your own, so I'm going to leave those for you. Next up, which of the following is the equation of the x-axis? So what we can do is we can test each one of these answer choices. The line x equals 1 crosses the x-axis at 1. So on the x-axis, here's 1. Here's the line that crosses it at 1. This line is not the same line as our x-axis. Next up, we've got the line that crosses the x-axis at 0. So we go to 0 on the x-axis, and we cross the x-axis at 0. This line is also not the x-axis. So this actually, you can see that the pink line we just drew overlaps exactly the y-axis. So this pink line, x equals 0, is the y-axis. And then we've got y equals 0. So on the y-axis, we go to 0. And we draw the line crossing the y-axis at 0. And that is the exact same line as the x-axis. So this is it. Next up, for problem number 3, we've got what is the equation of the y-axis, and I think if you were paying attention before, this answer should be clear, so you figure it out. Okay, next up for problem number 4, write the interval shown in each of the following, there's a word missing there, but in each of the following problems using inequality notation. So inequality notation will mean using inequalities like less than, greater than, less than or equal to, or greater than or equal to. So looking at this number line, the x values in this interval are the x values that are -3 is going to be the smallest x value on this interval. -3 is less than all of these x values on the interval. And all the x values on the interval are going to be less than 2 because 2 is the maximum. I'll put minimum for -3. Next up, the last thing we have to figure out is, do either of these less than signs need to be adapted to less than or equal to? And it looks like, because we have the solid bubble here, x can't equal -3, but because it's the open bubble here, x cannot equal 2. For problem letter B, you guys can figure this one out, so I'll leave that for you. For number 5, write the interval shown in each of the following problems using inequality notation. On your problem set, I actually changed this. Didn't get a chance to change it on mine, but it's supposed to say interval notation. So interval notation is the one that uses different kinds of parentheses in order to indicate the interval. So in problem A, we've got our interval going from a minimum value of -3 to a maximum value of 2. So we have all the x values from -3 to 2. And now we only need to choose what parentheses to use for our interval notation. Because we have a solid bubble here, x can equal -3, so we use a square bracket from the solid bubble. And from the open bubble, we use a curly parenthesis. I'm going to leave you guys part B again, so hopefully you figure that out. For question number 6, let g of x be the function graphed below. Determine the domain and range of the graph function in inequality notation. So domain are all of the included x values, so we'll start with that. Sorry, domain, here we go. So looking at our graph, we have all of these x values. Well, every point I guess has x and y values, but all the x values of these points fall between this x value and this x value. So we have x equals -3 is the lowest x value that appears, and x equals 8 is the highest x value that appears. That means that our domain is -3 is going to be smaller than all of the x values that are in between, and all the x values that are in between are going to be smaller than 8. And lastly, because we have solid bubbles at both ends, it means that both of those points are included. And so we have -3 is less than or equal to x, which is less than or equal to 8. For the range, we're going to be doing the exact same thing, except in the y direction. So we want to figure out what's the lowest y value, the lowest y coordinate that appears on this whole graph. And the lowest y coordinate is going to be right here. Because if we try to move that up or down, let's see if I can do this on here. Nope, I guess I can't do it like I did in class. But if you try to move that line up or down, if you try to move it up, you'll have some y values that go past it. So this is the lowest y value. You've got y equals -9. And the highest y value, we have to put our line here, which is y equals 6. Otherwise, we'd have points going past that line. Okay, so our range is y starts at -9, which is less than all of the other y values, which is going to be less than, all the y values are going to be less than 6. And that means that we'll fall in this range from -9 to 6 for every point. Similar to x with the domain, we have the possibility of being equal to those two values because we have solid bubbles at the top here and here. I think one last thing I'd like to point out here is that if you take a look at your domain and range, they form a perfect box. And that box traps the function within it. And so if you've done your domain and range right, you'll have no extra points in the box and also no parts of the function falling out of this box. Next up, we need to do these in interval notation. So because we have -3 to 8, and -3 and 8 are both included, we have the following for our domain. And for our range, similarly, from -9 to 6, both are included, so we'll have square brackets. And those are the final answers for parts A and B. Problem number 7 says a scientist observes how bacterial colonies grow on petri dishes with different levels of acidity pH. A graph of their data is shown below. What are the domain and range of the scientist's graph? So for domain is going to be the x values. If we look at our graph, it looks like the lowest x value that appears is 5. So 5 will be less than all of the x values that appear on this graph. And all the x values that appear on this graph will be less than 9 because 9 is the cutoff at the tip. Similar to before, we've got solid bubbles at the end, which mean we have the possibility that we could equal 5 and we can equal 9. So I should use less than or equal to signs. For the range, same thing, but in the y direction. So our range looks like this is not going to be the minimum. It looks like it gets a little lower over here, so this is the minimum. So our range must be that 5 is the lowest y value, which is less than all of the other y values. And all of these y values that are in between, the highest y value that we hit is right here. And so the top of our range is going to be 70. So the range is from 5 to 70, and because we had solid bubbles on top and bottom, we had the possibility of being equal to, and so this is our range. Because in this problem it didn't say inequality or interval notation, you're able to choose whichever one you prefer better. I prefer inequality notation, so I used inequality notation for my final answers right here and here. If you chose interval notation, your final answers would look like this. 5 to 9, both are included. 5 to 70, both are included.